Welcome everyone to the beginning of a new build. This system is going to be called Tritium. First of all, we're faced with a Singularity Computers flight case. This is our most high-end shipping option. We build these by hand, normally for brand new systems, but also quite often we ship these out to customers to pick up their builds, sometimes for a rebuild and upgrades, sometimes for case mods or custom paint, but most often because the customer has already purchased all of the components, and that was the case with this system. Now let me see if I can briefly explain the ideas and the theme for this build, which are very involved. I really love what the customer has come up with. It's kind of right along my way of thinking and a little reminiscent of Cytotoxic Build 8, another theme build that we've done in the past. So tritium is a radioactive isotope of hydrogen, hydrogen-3. Protium, one of our product lines, protium is hydrogen-1, another radioactive isotope. Now, tri, meaning 3, refers to the proton and 2 neutrons which make up the nucleus of tritium. And to tie in the 3, the central part of the build, and not just the central feature in terms of the aesthetics, but it's central in many different ways. It's a central hub for the loop, the coolant, and it's extremely inherent to the design. We're using 3 Bitspower hexagon reservoirs. So also hexagons play a huge part with the Hexgear R80 case. We have, hexagons all over the case, all over the Bitspower components, 30-degree angles in the corners of hexagons. So again, the 3, and we have 30 and 60-degree fittings, but I'll go more into all of this as we go. As you can see, quite involved, but really cool ideas. Now, the color scheme for this build, as you might be able to imagine, is going to be quite industrial. Think kind of nuclear reactor, a lot of gray, silver, metals. We're going to have a gunmetal metallic for the case. Also a black candy over a silver metallic with a silver flake. Super excited about the custom paint for this build. Now, anyway, you can see what we have here is the Hexgear R80. I've never had any Hexgear case in the workshop, so this is a first for me. There are many firsts in this build, which I'm really excited about. I always love the opportunity to do something even slightly different. And it's not often that I get to do that. It's also not often that I get to do this level of customization. Not many people kind of really want to, because what we focus on, we're not really modders. We're building customer systems. And what customers care about is quality and also something that is going to retain its value. And that's kind of more our focus. Now, the customer mentioned that he wanted to do an upgrade. He said, send me back the motherboard, which was the Rampage 5 Edition 10, and the CPU, which was the 6900K, and the Bitspower monoblock, which you saw in the case. I'm going to be sending you some new components. And a few days later, this arrived. A AMD Ryzen Threadripper 1950X, Asus ROG Zenith Extreme, 128 gigabytes of Corsair Dominator Platinum SE Chrome memory. And I'm not even going to start on the rest of the components, but anyway, now we're going to jump straight into the case mods, and the first thing we're going to be looking at are these reservoirs. We've got a perfect opportunity. We've got a hub here to shorten the tube lengths. Why are we going to go do these huge, big, long 500mm lengths if we have something like that? Problem is, if we're going to use it, we either have to separate it, like I said to begin with, completely separate it, and do it all in series. It's a lot of components in series, but very little resistance here, so this counts kind of just as one. But it still is a lot of parts in series. If you put them in parallel, you're decreasing the resistance, but you've got to have more flow to fill all that volume that you're creating. So after an hour of discussing this parallel configuration, which kind of blew our minds a bit, because you got to think about it in terms of how many directions the flow has to go, obviously, and you got this first one, then you got the second one, but by the time you get to the first one, it already has 4 different directions, and then 8 different directions, and then it just gets ridiculous. It's way too many directions that it can go. It's too much parallel. So we're going to keep these 3 separate. It's going to stay in series. We're going to keep one pump. We were thinking about adding a second one up high, but it's going to have problems if we do that. Filling the loop. Once it's full, it would be fine. And actually, if you laid it flat and filled it, it would also be fine. But I don't know. It's not really what the customer wanted anyway. So what we're going to do, come out of the pump, into the lower radiator. We're going to come out. There's going to be a shroud in here, by the way. So the PSU and the cables are going to be covered. The shroud's going to come around like that, and then across here at the height of these. So these are going to be lifted up to here. So there's going to be a huge gap behind them, which we're going to run all the cables through. So we'll come out of the pump, into here, out through the back out here, through this res, into the graphics cards, around in parallel, back out, into the monoblock, out of the monoblock, into this one, out of that one, into there, out of there, back into there, and then straight into the pump. So that's a full series loop. The only thing in parallel is the GPUs. The customer planned this out really well. You can see his mock-up here. We've roughly drawn it up here, but we need to get more accurate measurements. So we're going to have a 15mm bent section up here to connect to the acrylic. We're going to use countersunk screws on there so that the acrylic can still meet up against this panel, and so that there is no mounting holes visible or screws on this front panel. We don't want to do that. So first we have the 15mm bend, then we're going to come out 90mm. Now the full height of the power supply is 150. So 150, and the height of the reservoirs is 65. So 85 from 150 is what, 65. So that's going to be the gap. There's going to be a 65mm gap in under these reservoirs.
Yes.
To get them up to the height of this power supply. So yeah, 85 down, step. And where's that going to bring us to on these radiators? See, that brings us about halfway up the radiators. So it means that the airflow from the radiators is going to be blowing behind the shroud and in front of the shroud, but just a very thin panel, you know, kind of dividing the air, which doesn't matter. I want to have a 15mm gap above. So the shroud will be like here, and it will have a bit of a gap. I don't want it sitting like right, you know, on this. Finally, I get to lay hands on this beautiful component, the AMD Ryzen Threadripper 1950X. This is the first Threadripper PC that we're building here at Singularity Computers, and certainly the first of many to come. But it's an interesting moment, which we're certainly going to make the most of. It is almost nostalgic. It brings back great memories for me of Clawhammer. And I actually owned a 3200 Plus back in the day, but I just cannot wait to get this system up and running to do some testing. I mean, take a look at the size difference here. I kind of feel bad that the customer doesn't have the privilege of doing this, but he gave it to us so that we could share it with all of you. So awesome. Let's break her open.
All right, let's check it out. Here we go. Yeah, look at that. If you can see, this just slides out. This is a precaution. And let's get the big chip in here. It's just, you feel way more safe on handling this.
Yeah, it's a great system because, you know, Intel has had quite some problems with
there we go, it clicks.
Pins being in the socket. It's, you know, they always include that warning.
Yeah, you can see it. Just pull from here in order to remove. And yeah. Alright, let's bring this bad boy down. There we go. It clicks, stays in place.
Nice.
Yeah. Let's try to close this up now.
There you go. They're both tight now, or they're all tight.
Yeah, let's check out the last one here.
All good.
Yeah. Yeah, but definitely, yeah, you had to pull really hard down there, so the thread was a little bit short, seems to be.
Just, yeah, it requires a lot of pressure, which is not surprising. Anyway, let's move on to installing the memory and the cooler and get this thing up and running. So let's take a look at this EK Supremacy Evo Threadripper Edition CPU water block. Really looking forward to taking a look at what EK has done here. I haven't even seen this thing yet. It actually looks exactly the same as the normal Supremacy, just with a different hold down plate. But there must be more surface area underneath. You know, just because of the sheer size of this thing. Yeah, so we have more surface area here. There's Sven.
Nice.
Say hello.
Can you see me?
So yeah, they've basically used exactly the same components as the EK Supremacy, the top acrylic section, the internal acrylic section for flow direction, and looks like the same jet plate design and everything. It's only the bottom copper section that's been slightly expanded, and then we have a different hold down plate and retention system. But yeah, we don't really have the surface area here for the chip. Like, it's not going to...
Other way around. That's... Yeah, the gap is smaller.
Not going to get full coverage, eh? But close to it, I think. Okay, let's install some thermal paste. Quite a lot of it.
Yeah.
There's no doubt about that. And it's quite an easy installation, you know, there's no back plates or anything to worry about. Thanks to the retention system, it's going to be, yeah, really easy installation.
All right. I think there's not going to be enough in this one.
I think we'll cut how we do our thermal paste so that we can avoid that whole thermal paste argument. The system is up and running, and we're into the BIOS, and we're just about to take a quick look through at the features to see what we have here. This is always the first thing that I do when I boot up any new motherboard that I've never seen before, straight into the BIOS, because that's really what I care about the most. You can see the awesome Strix GPUs. They just look amazing with the RGB features. They have huge fin arrays. The fans obviously don't need to run a lot of the time, only when they come under load. So yeah, they're not even cutting in yet. But when they do, they're so quiet. I mean, we have 3 fans and then this huge fin array. So the power supply fan won't be running either. But that loud fan that you can hear is actually the little 25 or 30 millimeter fan. So that's quite loud, but only because we're in the BIOS. As soon as we get out of the BIOS, that thing's going to drop right down. But that's always the problem with these tiny little fans. They're always loud, at least at max RPM. And so as soon as I saw that, I knew that we were going to hear that, you know, a little bit of whining. But yeah, it's only while we're in the BIOS. I guarantee you when we boot, it's going to be absolutely inaudible, because right now it's running at 7,000 RPM, so that will probably drop down to about 1,500 or 2,000. Now, according to the features on the motherboard box, this is actually a little OLED screen. But obviously Q code there, but really, really fancy way of doing it. Nice place to put it there too, where it's going to be visible. Code A9 currently, we're in the BIOS. And while the system was booting for the first time, you know, always when you boot with a new CPU and new memory, it takes a while. But I was watching the LEDs there. You can see where that green and those 2 orange LEDs are. So those orange ones are for the PCIe slots, and you can see there's dip switches there for them as well. And they're lit up, they're orange because of the 2 GPUs that are currently installed. The green one below it there is for the, well, it's for one of the components. I think it might be the CPU or something, but there's 4 there. CPU, memory, GPU, and then boot. Yeah, so that one's for boot. And during post, they light up and they tell you if there's a problem. And take a look at that ROG DIM.2. That is just the coolest feature ever. We've now installed the latest drivers. BIOS is up to date. Everything is ready to go. All of the benchmarks are installed. And I thought you could join us for this first experience with Cinebench. We have Ada64 running in the sidebar, showing all 32 cores, the activity. And as soon as I start this, it's just going to go straight off the screen. So the last time we ran Cinebench was yesterday on a 7700K running at 5.3 gigahertz, and we scored about 1150 or something. Look at how fast that is, and how many of them there are. 3063.